Hey guys, how's it going? I hope everyone's doing all right, and it's good to see y'all. SE Woods, yes, it is about time we got some more streaming. Last Saturday, I was just like, I needed some time, and so I just played Breath of the Wild all day and like chilled. It was nice. But today is all about coding, so we're gonna be good. Voxverse, how's it going? Stolen title, absolutely. I don't know if we're actually going to be doing caves and cliffs. I'm going to leave that up to you guys. We'll wait a little bit. I'm going to fix some bugs, and then once we get a few more people up, we're going to see if we want to do something else, because I have a few different options. I just didn't know what people would be more interested in seeing. So yeah. And Flare YouTube, how's it going? I'm doing good. How are you? So yep, I never left. I was working on stuff, so we can sort of check out Flaming Knight. How's it going? We can check out what I've got going. The main HUD, the cube map here, doesn't look as good. I got to get some more interesting terrain so that we can have a better looking map here whenever that's finally working. The trees also look kind of weird right now, and that's just because of some lighting issues, and I think it's order independent transparency issues, which I will be fixing as well pretty soon. But yeah. SE Woods, you missed the stream 2 weeks ago. Oh, okay, so it has been some time since you watched last stream. So there is no, okay, I gotta delete this first of all, real quickly. There's no, what was I gonna say? I'm still waking up, guys. I have no idea what I was gonna say. There's no something, so we'll keep that in mind. But anyways, I have been working a lot on the clone in the past. So there's a lot of progress. You can see I sort of started adding like the screenshots here. They don't look really good because I haven't gotten it so that the pause menu disappears before the screenshot actually finishes. And then I also have to center this text and stuff because it doesn't look very good. But I did add like, there was issues where like if you went off the edge of a text box, it didn't work very well. So I just fixed that really quick. So there was an issue here, but now if you keep going, it just deletes that stuff. And then you can also hold backspace, which is nice too. Didn't have that either, which was annoying. I also needed to have a cancel button there because it's really annoying to just have to close down the whole thing in order to redo that. Yep. Joe Mega, good to see you too. Flaming Knight, we might be doing terrain generation, but I'm going to fix a couple bugs first, and then we're going to sort of see what people would rather see, because I'm kind of split between either terrain generation or like dynamically creating models for items and stuff, right? So I've got a lot of tabs open up down here too. So I'm editing and everything, and the video is coming along good, but editing always is a mess in my whole desktop. But if we take a look at the assets, we've got these items, and I think this could be an interesting thing, but I don't know if people are interested to see this. So, right, you've got like these types of things where this is something that when you're holding it in Minecraft, it's like an actual 3D object. And so I think it might be cool to like actually, okay, you think that definitely sounds more interesting? Yeah. So we're going to see what other people think, because I want to go and start exploring that, just how you could dynamically generate the 3D models and stuff. I don't think it should be too difficult. But I was working on terrain generation before, so I didn't know if people might want to see that instead. But yeah, in Minecraft, everything you hold is 3D, which it's interesting because they don't have any models for that actually. But let's go ahead. I'm going to delete the rest of the worlds here so that we can actually see some of the changes I've made since last time. So that's also nice. They all update automatically, which is pretty cool. But anyways, let's go and create a test world. I have added, first of all, loading screen here. The loading screen is pretty simple. I'll explain it in a little bit. You'll also notice terrain generation is quite different, and I'm still working out more stuff. But if we go ahead and like set the time just so that we can see stuff. Set time to that. So you can kind of see it looks pretty different. I'm not going to move too far because I also want to show off another feature that will break if I move too far. So, oh yeah. And then we've also got this little thing, which just tells us where to look for experimenting with noise. So basically, that brings us to the next thing. Let's move this over here. Since noise has been what I've been working on, I sort of wanted to parameterize it so that it's really easy to tweak values and just start experimenting with stuff. So I load all the noise generation stuff from a YAML file. And if you want to see how that's actually going to affect your noise stuff, I'm going to open up my downloads because I downloaded, yeah, okay, so there's this thing that you can download from a repository on GitHub. Basically, if you take a look at it, it just shows some noise values, which is cool, but these things are like directly one-to-one mapped to the YAML. So you'll notice like, if I can't shrink that, okay. But anyways, if you notice, I've got like this weight, this is different, but we'll talk about that in a minute. But then I've got like general, you'll notice we have general over here, and then I've got noise type, frequency, and then frequency. The seed is generated automatically. You don't have to worry about that. I'm not sure I'm going to do the rotation types and stuff yet. But this is the basic premise. So you can go around, experiment with stuff in here, figure out how you want to do it. So let's say I wanted to like have a really high frequency, which makes this look way noisier. So we get this super high noisy value. Then if I wanted to see what that would look like, I could go ahead and let's go ahead, comment that out, and I'll do 1.00 here, which this is going to generate or change the generation for this part, right? So we should expect to see some super noisy terrain. And since this is weighted at 1, I've actually got 5 noise generators here. And right now I'm only using the 3, I think. Yeah, I'm only using these 3. These weights like are sort of how much impact they'll have on the overall terrain generation. So this one has the most impact right now. So then if we go, we can say regenerate terrain or regenerate world. Yeah, that's it. It's like lagging, I think, because yeah, my cursor's stuck in there because of how noisy that was. That might not have been a good idea, but we'll see if it works. I'm still streaming, so that's good. I'm actually not sure what's happening here. This is weird. Let's go ahead and pop that out. Oh, it's because I selected that stuff. Okay, there we go. Yeah, so then it goes ahead. You'll see there's a bunch of warnings up there because of how noisy this is. I'm running out of room, like memory and stuff for Vertex data, which isn't good. But we'll let that finish, and then we can sort of see what it generates. I'm also going to catch up on chat real quick. Yeah, Voxer, should not be too difficult. Those are famous last words. I should know that. But I really don't think it'll be too hard this time. Hot reload, sort of a hot reload. This is like, I just sort of have some code built in to work on this stuff and automatically regenerate the terrain. It uses a lot of the built-in functionality that I already had for like exiting a game and then reopening it. So it's basically doing that. Essie Woods, you have a question. Some games are really dependent on the ping. Would it be possible to cap a ping to be minimum of 50, like 50 milliseconds, so that no one would have lower ping than 50? Could possibly also have Googled it, but hey, we got some brain power. Yeah, so you could definitely cap it. I mean, to be a minute. Well, actually, I don't think you can. So 50 like you can't really force it to be a certain time for the ping because it's all dependent on like the network and everything. So if somebody has a bad network, they're just kind of stuck with that, you know? And the thing is, you actually don't have to worry about having that great of a network. I was reading up on some more advanced techniques that like Valve does for their FPS and everything, like or their more dynamic multiplayer games. I think CS:GO, is that Valve? I don't know. Anyways, I was reading up on it, and they do some interesting stuff. So basically what they do, which is, this is the same concept they use in video streaming software and everything too, because think about it. If you hop on a Zoom call, or even you guys are watching me right now, there's a crap ton of data being sent to you guys, and there's no way they can send it to you instantly so that my audio isn't glitching or my video isn't glitching. But you guys all get to see it semi-smooth. And so how do they do that? Well, what they do is they actually offset it by like 1 to 200 milliseconds, right? Because that's pretty easy to maintain. And so what they'll do is they'll send you guys 100 to 200 milliseconds of footage behind where I'm actually at in real life. That way, if there's any hitches in like the network or whatever, you've got a little nice 100 to 200 millisecond buffer. And so you kind of fill that up. And then as you continue going, you just kind of continue moving from that buffer. And that's sort of the same concept that a lot of live multiplayer games do as well. They'll have like 100 millisecond buffer. And then if the network hitches or something, the other players won't feel it, and the one player who's playing won't feel it, and they'll just interpolate the physics and everything from the last known update. So, yeah, I've seen like Valve was talking about 100 millisecond buffer for games, yeah, because what they'll do is they'll interpolate it, and if you shoot somebody in your version of it, Yeah, I'll find the article and send it to you guys so you can take a look if you want. But it was interesting. And it was an older article too. So like, especially you had games back in the early mid 2000s that were doing multiplayer somehow. And we finally have it loaded. So computer engineer, most games are lower now though, like 50 milliseconds ping. Also, hi, how's it going? So yeah, you'll see that now that this is finally loaded, the only reason it took so long is because of all those logs. They lock on multi-threads, and that was a multi-threaded process, so it had horrible synchronization issues, which is why it completely took so long. But yeah, terrain is super, super noisy because of what we did. So then if I go ahead and I just change this back to what it was before, we will go back to what I had before. Because, is that what I called it? Reload, regenerate. Terrain, no, world. And this text box feels weird. Okay, yeah. So then you'll notice that I am back in the world we were in before because it maintains the seed and everything as well, which is nice. I think I can actually show you guys that too. It should say it's somewhere here. We're not going to find it past all that stuff. Yeah. Oh, no, and I'm not actually relogging it anyways. But yeah, it does maintain the same seed and everything too, so that when you're messing around with the noise stuff, you're seeing the changes as it would be in the seed that you're already in, which is pretty cool. Yeah. I need /help. I do need /help. Yeah, it doesn't do anything. One day. I still don't have chat though. So like if you just type something, it just does nothing. So I also need to implement that. The reason I'm kind of waiting is because I'm thinking of like switching GUI stuff, because I really don't know if I want to do GUI stuff by myself. And there are some cool HTML libraries that you can do some much more interesting things with. But yeah. Okay, so that's sort of caught up on everything we have so far. I've also fixed just like a lot of bugs and everything. So it should be a lot more stable now. I kind of worked on the terrain serialization and deserialization, entity serialization and deserialization. I fixed a lot of those bugs. You'll notice as you go farther out, the lighting is not recalculating on the edges, which is bad. And then also, we are not getting our terrain recalculated as well, which is also bad. And so that was one of the bugs I wanted to fix because it should be pretty quick. Yeah, so you'll see we're getting holes here because this terrain is not actually being regenerated. It's not bugs in the actual terrain, because if I drop down and then save and exit and then reopen this world, I'll be in the same spot. And now those holes are filled. It's just because I'm not regenerating that stuff as you move, and the lighting is all fixed too. So we can fix that pretty easily. All we got to do is just make sure that if a chunk was on the border beforehand, it gets regenerated as we move. So let's do that real quickly. And Joe Mega, they use 0.1 second as a buffer because of the server ticks 20 seconds a time. Yeah, and that's also an interesting thing. The server ticks 20 seconds, 20 times a second, right? 20 ticks a second, which is not 60 frames per second. And so that's kind of when I think it's funny too. If you talk to a lot of FPS players, they're like, oh, latency, like you have to avoid minimum latency, blah, 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 because the smallest change in latency will ruin my gameplay experience. And so they buy these 144 hertz refresh rates, and it's like, dude, you may have 144 hertz on your client, but there's no way that you're going to get that frame rate going across the network, even if you got gigabit internet or whatever, right? And so I don't understand it. I think maybe it has a difference, but you're working on like interpolated physics values and everything that the games do behind the scenes. And so you're not actually getting that frame rate, especially if somebody else is on a lagging machine. They're not going to see you that fast. So I don't know. I just think it's funny. But yeah. And it seems regular CSGO servers run at 64 ticks per second and professional servers run at 128 ticks per second. Okay, yeah. And that's what I would expect from like more professional stuff. I'll see if I can find the Valve multiplayer networking. See if I can find that article. I think this might have been it. Yeah, this is it. So if you guys want to check it out, this is really, it's a long article, I think. Is this the one? Yeah, this is the one. So they're kind of showing what's happening here. So basically, if you're lagging, this is where the player's in real life. This is where it was when you shot. And so it calculates, you know, to see where you're actually seeing and stuff. And it does all sorts of cool things. But yeah, paste that. You guys can check that out if you want. It's a great article. But let's go ahead and fix that bug very quickly. It should be pretty easy to fix. So I've also refactored a lot of code. So this is a much smaller file now. I kind of broke up all the chunk stuff into separate files for each specific component. So like if we go into the world, we've got chunk.hpp, which is just about chunks. We've got chunk manager, which is about loading them and stuff. The thread worker, which is about all the multi-threading stuff. And terrain generator, which is about noise generation. So kind of encapsulated more nicely instead of having a giant like 2,000 line file. So, yep. Anyways, I think this is where we want to be for reloading chunks. We can look for check chunk radius, and this is what happens. So let's take a look. So first we say remove out of range chunks, which basically goes to see which chunks are loaded. If they're not in range anymore, we just say save the chunk, and then, yeah. And then we say unload any chunks that have been deserialized. So then this goes through and it just says, if anything is already done unloading, yeah, just remove it from our pool. We don't need it anymore. Okay, then we go. Okay, so this is what I'm going to be checking. So this retest light edges thing is basically saying like, check and see if the chunks that were on the edge, the last frame. So the last time we moved, which is what this thing is checking. It's basically saying if we moved and we just like brought in new chunks, then retessellate the chunks that were on the edge previously. And I think this should be a really easy fix. I think it's just something down here. Let's see. So this says retessellate edges is true. Okay, and then it doesn't look like I'm actually using that, which might be the problem. Yeah, okay, wait, right here. So retessellate this chunk. Basically checks to see if, yep, okay, so this is what it is. I just changed, wait, no, this looks right. So we check to see if the chunk is -1 of our chunk radius, and we're supposed to be retessellating the edges. And if that's true, then we queue it for retessellation. Yeah, if it's false, we just queue it for creation. Okay, this looks right. Let me decrease this to 2 to see if that fixes that. So if we do chunk radius -2, do we get the proper behavior? And so basically all that's doing is it's saying if a chunk was like within the radius -2 and we just generated a bunch of new chunks, retessellate those. So let's see if that fixes it. I'm not sure why I would have to have it at -2 though, which is probably something I should look into a little bit deeper because that's not good. But if this fixes it, I'll be happy for now and then we can move on to better things. No, okay, so, well actually the lighting, I have to do that differently too. So we'll check out the lighting in a minute. This should fix the holes though if they were showing up, and I think it is. Yep, I think we have no more holes now. Let's just go a little bit farther. Nope, we do have holes. Okay, so something is still going wrong here, which is weird. Yeah, we shouldn't be getting this. Oh yeah, and the lighting should get fixed. Well, I don't know, because the retessellation might not fix that, yeah. But yeah, I'm not quite sure why we're getting that. There is no more flat shading. Well, okay, yeah, I don't have ambient occlusion, but smooth shading between light levels and stuff. So I need to add ambient occlusion at some point. Should it be or retessellate edges instead of and? Oh, did I just have a logic error there? Oh, no, because this is checking like if the chunk is greater than or equal to our radius -2. Yeah, and we need to retessellate the edges. So this is basically checking to see like if we're retessellating them and it was within that radius -2 area. But this makes me think this might be wrong. Let's draw this out. This is a perfect opportunity for drawing something because I need that. So let's switch over real quickly. Okay, so I probably have a drawing in here somewhere too where I was already experimenting with that. But anyways, let's go ahead. So basically what we've got is we've got like our chunk radius, which is actually, I mean, I guess it's technically a circle, but it doesn't matter. I guess it kind of does matter. Okay, let's do a circle instead. So we got our chunk radius, which is like here, right? And the player's last load position was somewhere in here, we'll say. So the player last loaded here, and this is like a chunk area. And so once the player moves outside of this bounds, then we get a new chunk area, which would be like something like that. And his last load position is here. So then we would get a new chunk area, which I'll do in red, which is like around this new area. And what we want to do is we want to say, okay, all of these chunks should be retessellated. Is that right? No. We want to say all of these chunks should be retessellated. Yeah. Because these ones are fine. These just, yeah, these were within the bounds before, but these ones are not fine. So what we want to check is we want to check and see, whoops, that should be red or orange, I guess. We want to check and see if these are within, like on the last radius of our last player load position, right? So maybe we just check and see if it was on the radius of our last player load position, retessellate. I think that should work. I don't know if that made any sense. Hopefully it did, but let's try that out and see if it works. Okay. So instead of using, wait, yeah, we are using our last local pose, which is the last position. Oh, wait, but I also have this thing up here. Okay, yeah, no, this is good. This is good. Okay, so this checks and see, first of all, if the chunk is within the radius. If it is, then we want to load it or retessellate it. And then if it is, we want to check and see if the last local pose, yeah, this does look right. If the distance is greater than or equal to the chunk radius minus 1, which should have been fine, then we should say retesslate. And I got to switch these because this is confusing me. So let's put this up here. Put this down here and switch this to a true condition. So if it's true, then we do that. That just makes more sense. Joe Omega, flat shading. Yeah. So no ambient occlusion. I got to fix that. CGO clan, you're late, but who cares? Also, big fat. Okay. Good to see you, CGO clan. Okay, so this looks right to me, right? We basically have the last position that we loaded at. And if the square from that last local position... Oh, wait, I'm not subtracting anything here, though. Is this right? So I say last... Oh, okay, no, this isn't local coordinates. So last local position is last player's position in chunk coordinates minus the position of this chunk. And then if the squared distance of that is greater than the squared radius, greater than or equal to the squared radius minus 2, we should retesslate. Maybe this flag is never being set, which is a real possibility. So when does this get set? This gets set if the last player's chunk coordinates does not equal our current chunk coordinates. And when does this get set? And this gets set right here. Wait, no, this is static though. Okay, so when does it get reset? Okay, and then it gets reset at the end of it. So that should be fine. So then if this ever changes to the next frame, they should be different by the time we get into here. And then this would be true. Let's see if we ever hit this. I'll put a breakpoint in here real quickly. I should probably be on debug mode too, but it's fine. Block Builder, YouTube, what am I making? I am making Minecraft clone. So right now I'm just working on fixing a bug, which is faces that are out of range have holes in them, which is easier to show it than it is to just kind of describe it. So let's see if it fixed it. If it did, then I'm working on something else. So, okay, so we do hit this. So the last position, and I'm not going to get to see this because we're not in debug mode. So these got optimized away, which is annoying. But we are hitting this for sure. Let's hit continue and just see what happens when we keep going. Oh, I think I fell through the world or something. We're gonna have to regenerate a world because I don't know what happened there. Okay. Delete that real quickly. Yeah, that is a new record. I didn't even see it. Thanks, mods. Okay. So, test world. I don't think I fixed the problem because I didn't change anything, but we'll see what happens. I might change it to do like recalculate lighting instead so that it's immediately visible. Because if it recalculates the lighting, then we should see these all change. So I might change that in a minute just to see. And then that should also trigger retessellation as well, I think. So let's see if this is working now. I don't think it is, but it's worth a check. Yep, still broken. Okay, let's change that first of all to do recalculate lighting. What does this do? Let me just double check this too. So this checks to see if the chunk exists. If it does, it says to tessellate the vertices. Should this be, do I have a retessellate? No, I don't. Okay. So it says tessellate the vertices. And then it goes ahead and sets all of the sub chunks that need to be retessellated to retessellated. And then it says to start work. Okay, so that all looks fine. And I think it should recalculate lighting at the end of everything anyways. Let's just check that real quickly. Yeah, so I have Q calculate. Okay, but that's not recalculating lighting, so that would be why. Let's change this real quickly and just see if we get any different results. So we'll say Q recalculate lighting, chunk coordinates, which are this position. The block position that updated. Well, this might actually work because that's assuming that a block was updated. Okay, I'll have to think about this one a little bit more. Ambient occlusion is light not getting into corners or stuff like that. The thing I mentioned about lighting, I mentioned is literally just directional light. Think of the basing font. Removing one of the I mentioned from this sentence. No clue. Yeah, I know, but in Minecraft or in a Minecraft-like game, you don't really have... I mean, you can use the directional light to influence it, but here, I'll... Yeah, so you can check out this, but this is basically how you add that detail here. For a Minecraft-like game, you've got to do something different. So I am curious too. What is ambient occlusion? Yeah, it's basically like adding that detail. It is typically from a directional light, but ambient lighting and ambient occlusion doesn't necessarily have to be from the directional light, I don't think. Like any light source can give, well, I don't know, because there's so many different ways they use it. Sometimes they use it to mean just like the lowest light level and stuff, but yeah. I'm pretty sure you're talking about this. I'm pretty sure we're talking about the same thing and everything. Calusos, love your content. Thanks. Good to see you here. And S.E. Woods, Breath of the Wild, from 1 out of 10. I hope that meant to be a 10 out of 10 because I really enjoyed Breath of the Wild. Or yeah, Zelda, right? But, or at least I'm really enjoying it so far. I don't know. Okay. So we are hitting this. Let's do something. If we're retesslating it, let's go ahead and just make this do something a little bit different so that we know that it has been retesslated. Let's like have it submit weird colors or something. So this is going to set it to subchunk state to retesslate. And then if we go into chunk, I'm going to close all this stuff out. Oh, I closed everything out. Whatever. Okay, so let's go into chunk manager.cpp and chunk.cpp. Okay. And then let's go down here, and if we're reteslating a block, I'm going to make it super obvious that the whole chunk was reteslated, just to see if we actually are. And if we are, then I think I might know where the problem actually is. So let's go ahead and tessellate. Or what did I call it? Generate render data. Okay, there we go. This is what I was looking for. Okay, so let's add a flag here where basically we can tell if we're reteslating this or if it's just being tessellated for the first time. And then we can just like change it to a really weird color or something like that to make sure that we know what's happening. So generate render data, we will call this is retessellation equals false by default. Copy that, paste it into here. That way we can see which chunks are being reteslated, just to get a better idea of what's happening. Okay, so if we're reteslating, what do we want to do to make that super obvious? We could make it super obvious by just setting all the light levels to 0. So I think that's what I'll do. Yep. Okay, so then we'll just go down here. We'll say if is retessellation. We'll do something different. Else we'll do this. Copy that, paste it in here. Okay, so where are the light levels being passed in here? So we pass in the vertices, texture, the face, light levels. Okay, so then light levels are like, this has way too many parameters, by the way. Okay. So I think that's right here. I think that's this stuff. And this is just a vec4. Okay, so then we'll just set this to 0. So we'll say glm vec4. I guess this should be a U8 vec4 too, because that's what it looks like I'm using. 0. And I guess that's going to be an integer because that's what a U8 is. Okay. And then we'll do the same thing here. And let me just make sure that's right. Yeah, U8 vec4. Okay, cool. So we'll do that. That should make it super obvious what's happening. We also have to go into the thing that actually does that, which is the chunk thread worker. And change it up over here too. So when we retessellate in here, okay, so we got tessellate vertices. I think we can tell if this is retessellation, can we? We have no way to tell. Wait, no, yeah, we do. Okay. So this says retessellate chunk. This just says generate render data. Okay. Yeah, I don't think I have any way to tell if it's retesselating. Let's just add a flag here real quickly, just so that it's easy to tell. I think I have this fill chunk command. Yeah, okay. We'll just add in a Boolean here that says is reteslating. Okay, and then we'll go ahead and say, yeah, I think that should be fine. And then inside of here, we'll just pass that through this. So we'll say command dot is retessellate. Okay, cool. And then inside of the chunk manager, we can go ahead and just pass that through as well. When we say q retessellate chunk, we can just say cmd dot is reteslating equals true. Okay, so now whenever a chunk retessellates, it should get light levels of 0. Let's see if this works. Okay, Jomega, so this image shows with and without ambient occlusion. Take in mind that you both have directional lighting, not flat shading like you have. Yeah, so ambient occlusion is like the light between these things. And that's what I'm saying. Like I do have, there is lighting in the game. It's just not taking into account ambient occlusion. Like that's what the whole point of adding like the directional portions of the faces are and stuff. In the Minecraft-like games, they don't do like actual ambient occlusion because then you would need like every single light source and like actually calculating the faces, directional value, and that stuff. And they don't do any of that. This guy does take it into account a little bit here, but you basically just fake it by checking to see if you have blocks around you. And then if you do, you just kind of add a darker shadow there. So yeah, that's what I'm saying. Like it's like emulating ambient occlusion because there is no real ambient occlusion in the game. And there is no like directional values for the lighting values at all. Like if you notice in Minecraft, the direction of the sun, it might have an impact on the way this is generated, but it doesn't have any impact on like the way light sources go and stuff too. And like if you place a torch, it doesn't have any effect. If you place it over here, it just sort of darkens the same way across all directions. So that's kind of what I'm saying. I get what you're saying though. I know ambient occlusion is a thing. It's just not actually implemented in Minecraft the way you would think it is. Oh, SC Woods, you were asking my verdict from 1 to 10. Okay, I think let's go ahead and set this to 1000. Okay, so it looks like we have normal lighting here and stuff, which is good. But I think it's like probably like a 7 or 8. You haven't tried it yourself, yeah. I kind of put it off for a while because I heard mixed reviews and stuff, but I actually really enjoy it so far. So if you haven't played it, that would definitely be worthwhile. Okay, this is good. So we're definitely seeing this stuff getting retessellated. And I think this tells me that it's actually a different problem we're having. And that's why we're seeing these faces not get repopulated. I think it's probably because of the way I do pointers and stuff for chunk neighbors. We'll talk about that in a minute because these are definitely being retessellated, which is good to see. So yeah, we're still seeing the glitch. So let's go ahead. And I also have that timing there because I was checking some other stuff too. Okay, but anyways, so what is happening here, or what I'm guessing is happening here, is I've got this thing inside of the chunks to make it easier to traverse if you're going like from neighbor to neighbor. So I basically just store a pointer to the different neighbors because those pointers are stable and they're not going to change from different calculations and stuff. And I think what's happening here is if we go into the chunk manager, when we check chunk radius, I have to patch these chunk pointers when we generate new chunks, right? And so I think what's happening is we're actually generating the new chunks too late. Yeah, so I have this thing called patch chunk pointers, which should fix all of them up. And maybe I should be doing that before we create the chunks. Is retessellate higher priority than create chunk? I should check that. I don't think they actually have any priority, actually. Well, yeah, I think create chunk has higher priority. Let's check that real quickly. So generate terrain, which is what the create chunk should be doing, does have higher priority. So this is highest priority, this is lowest priority. Okay, yeah, so tessellate vertices is at the bottom. So I think what I got to do is I just have to say, I think I just have to patch the chunk pointers up here instead. I think that's all it should be. But the reason I'm hesitating is because what does this do? This does it immediately. Yeah. Yeah, so this does it immediately, which is bad because we don't actually have those new chunks generated yet. Joe Mega double checked it, and yes, Minecraft does have some directional lighting. If it was just ambient occlusion, the sides of the stone bricks would all be lit on the same side. Since ambient occlusion does not care about light direction, but these blocks are lit differently on their sides. Yeah, but it's definitely not the typical way you implement ambient occlusion. Because, like, yeah, I tried it with the traditional, like, Phong-based lighting model and all that stuff. And the first part, and trust me, it doesn't look like Minecraft does. I think what they're doing is they're doing something similar to what this guy is doing when I had it open. And then based on the direction, which is what he's also doing in that article, you just give it a higher strength or a lower strength of how light that level should be. And collector of stuff, not GitHub or ! GitHub. Okay, yeah. So I think this is probably what's wrong. But not completely, because I don't think this should affect stuff. Because that shouldn't affect... Yeah. Because those chunks, so those pointers should still be okay, is what I'm basically saying. Because those pointers shouldn't have really changed, which is why it's kind of weird that it doesn't. So they basically add directional lighting in what they call ambient occlusion. Yeah, that's what I was saying. So I was trying to keep the terminology the same as like what Minecraft is using and everything. But yeah, not actual ambient occlusion in the traditional sense of like the way AAA games do it and stuff. Yeah, because what I'm thinking of here is basically the neighbors, the chunk pointer should be fine for those specific neighbors. So I don't actually think that's what's causing it. Let's go into our generate rendered data thing and see what exactly is happening in there. Yeah, so inside of here, what do? We say get block internal. So this gets the block that we're currently iterating over. And then if it's not an error block, we just skip it because it doesn't matter. Then we go ahead and we get all the blocks on all of its sides. And so this calls this function, which will basically check and see if it's inside this chunk or not. If it's outside of the chunk, it goes to get it from another chunk. SC Woods, thanks for donating $25. You just keep building that donation count up. But thank you. Okay, so we go. If it's outside of this chunk, we just say go to the neighbor. And then basically that recalls this recursively. And it says if the chunk doesn't exist, which means the chunk pointer wasn't set, then it returns null block. And if you get a null block returned, that basically just removes the face. So yeah. Hey, Eddie Dev, how's it going? Good to see you. So yeah, I think this should all be working right then, which is why it's kind of weirding me out. I don't think this is the actual problem, but we are definitely retesslating them. Is it because I'm removing the wrong sub chunks then? No, that can't be it too. This is just weird. Oh, and then the world got corrupted. I think I know what's happening there too. When the world gets corrupted like that, I'll just have to double check that and fix it later. I might put this problem aside for now though, and continue debugging later on so that we can get to some more interesting stuff, like what I was talking about before. Okay, yeah, because it's definitely retesslating these things. It's weird that it retesslated those chunks and not those chunks back there. Kind of strange. And I might want to look into that later. Yeah, but it looks like it's kind of retesting them as we go along. Yeah, so I might... Oh, wait, I think it was. Okay, it was the weird lighting and stuff. Okay, so I might take a look at this later. Wait, is it working now? Okay. It's working now. Did I move that patch chunk pointers thing? I think I did. Oh, okay, so I guess it was that. Because it's working now. Well, that's good. Cool, we fixed it. I was not expecting that to fix it. Let's go ahead and fix the lighting again, I guess. I'll leave it in there just in case I have to go and debug this again. But let's just check it a little bit more and make sure it actually is working. Because I wasn't expecting it to start working like that. So I'll just remove this for now, but I'll leave it in here. Okay, and then we'll remove that. Okay, let me just go explore a little bit more, make sure that it's actually working. What did I change? I changed inside of Chunk Manager. I moved that patch chunk pointers thing up a little bit. Yeah, so inside of check this. Wait, did I change it? No, I didn't. Okay, that's in the same place. Let's double check this again, because if it was working for that time but not for other times, that's just really weird. Set time to that. So if I travel over to here, let's see if it works. It might have just been that I thought it was working too, and it wasn't actually working. Okay, so where the lighting is broken, that's where it would start to be broken as well. I really need to add like a head bob animation too, because it's really weird seeing it just go super smooth. Okay, so that's fine. Okay, yeah, I think I was just looking at the wrong blocks. It is still broken. Okay, so I'll debug this later because it's definitely not fixed. I think I was looking at like these blocks which aren't on a chunk border, and since those are working anyways, I thought it was working. Okay, let's move on for now though to dynamically generating 3D models and stuff. So basically what we want to do is if we look inside of here, we have certain blocks like these things. Now boat, obviously, well actually, when you're holding a boat in Minecraft, is it like a flat 3D shape or is it like an actual boat that you're holding? I can't even think of that now, but that's besides the point. What we basically want to do is take an object like this and then extrapolate it into 3 dimensions by just extruding the vertices like 1 pixel, or I guess 1 world unit, whatever you want to call it, wherever there's alpha. So like around all these edges. I'm not even sure if it's actually around alpha. Let me open this up in Sprite real quick because I want to see how it actually looks. Right here. Okay, yeah, I think it does. So basically, we just want to extrude it along all the areas where the alpha is like below a certain threshold. Which shouldn't be too hard. Like, right, we just generate some dynamic model or whatever and just sort of submit it. And I have a way where we can just submit arbitrary triangles. It's not performant, but we can do that to test this to make sure it's working right. So we'll do that to test it and make sure it's all working right. And then we can go ahead and see how it actually works. So the thing that I'm wondering about though is how do we get UVs? Because, okay, so this is where it kind of gets interesting. Usually when you have an item like this and you want to put it Col alpha 0 only, right? I believe we want to do that, but there might be a case where you don't want to do that. I don't know. So I'm kind of thinking. But I'm wondering about UVs because usually when you're doing like 3D objects, right? What you do is you would like have 2 triangles that make a square, and then you would just do like UV for this corner and this corner, and then you just draw it, which is what I'm doing for the hotbar. But if all of a sudden I have vertices on every single corner, right? Every single pixel, do I like dynamically change those UVs to match where all this stuff is too in the actual texture? Or do I do something else? Because that's how you would do it in a typical 3D model, right? Each of these vertices would have it like where the actual UV coordinate is in the texture. And so that could get difficult. So yeah, I'm not quite sure what we're going to do about that. Creating the model itself shouldn't be too hard though, because we just got to kind of push those out into a 3rd dimension. So we'll do the model first and then worry about UVs later. Might be we have to do something, we might be able to interpolate it actually, just to get the correct stuff. So yeah. Okay, anyways though, that's the plan. So when we go ahead and generate or open our world, I guess, let's go into here. And actually, I'm going to go ahead and just uncomment that code again because I'm going to have to debug this later. Yeah, so let's go ahead and uncomment all of this so that I remember to debug that later. And then I'm going to push this real quickly just so that I don't forget it or commit it. Okay, so I'll add all that. And then just say begin debugging chunk faces, or I guess faces disappearing between chunks. Okay, cool. So let's go ahead and make the object first. Who made the apple? Whoever made Old Faithful texture pack. Definitely not me. Okay, so let's go ahead and go find where we start our application. I think I'm going to put all the code that we're going to do in there, but we start our application kind of like here. So let's check here and see what we do. Okay, so when we initialize everything, we initialize all this stuff. Vertices in it. Okay, this might actually be a good place to put this. This initializes some basic vertex data and then uploads it to the GPU. Yeah, so this basically just uploads a default quad, which is good. Yeah, and it's a 2D quad. So X, Y, and then UV0, UV1. So we might actually want to put it in here. So let's do that as well. Say vertices.h or constants.h, I guess. Okay, so I've got this vertices thing, and then we've got, and then this is just the VAO. Okay, so this might be what I do, because this would just be pretty easy to combine and everything. So I think I'm going to keep it all in here. And Langors, I think maybe make each pixel of the apple a cube. Should work and should be easy to implement, no? That would be good, but I think it'd probably be more performant if we just, because, you know, you have the possibility of having like hundreds, if not thousands of those on the ground. And if I have each of them as its own model, then I can use instancing, which means we can draw hundreds, if not thousands of models really quickly and fast. So yeah, I think I'm going to do it. And it shouldn't be too bad to get the UV data correct too. So what we'll do anyways is we'll have something in here, which is basically like, we'll have like a map actually. Let's do Robin Hood because it's a faster map. We'll have it be a flat map because we don't care about stuff being stable. And for now, it's just going to have like a string, and the string will go to a bunch of vertices, which we're going to say is like a std vector for now of floats. And we can change that up in the future. I might have like a vertex definition here. And this will be like item models. Okay. So this is the plan. And then we basically fill this up. Each of these strings will be the item's name, which we can get from here. So we'll only generate it based on which one of these are items. Yep. So these are items because we have isItem is true. Technically all things are items, but this is basically saying it's an item and you can't place it. So maybe I should change that in the future. But anyways, we've got this. We can get the name from here, right? This tells us what the picture is, and we'll just use that as our name to index into this and stuff too. So we've got this. Let's make a structure for a vertex because I really think that'll probably be good. Item vertex. I might have to have a special shader for this. I don't know. So I'm just going to create it custom. We'll have like a GLM vec3 position. We'll have, and that's gonna be like local position. I guess we need a glm vec2 UV as well. For now, it's not going to have anything. Okay, and that should be good. So we got position and UV. We might add more stuff to this in the future. And this will just be a vector of item vertex instead. Okay, so when we initialize, we need to create item models. And we might cache this and stuff too, so that on regeneration, we don't actually have to go and recreate everything. I don't know how fast that's going to be or not. Yeah. Sam, how's it going? It's good to see you here. We're working on generating dynamic models for items, which are these things somewhere in here. Okay, I'll check it out later. Hopefully we can get this working and then we can see it in action. So let's go ahead. We're gonna have a static void create models. This, and I called that item models. Copy that. Paste it here. Okay, so then what we're gonna do is, I think I have something in here which we can do very similarly. We have this load blocks thing. Okay, yeah, I'm just gonna copy this for now. And then we'll remove the stuff we don't need and kind of go from there. So go through all of that, copy that, paste it into here. Okay, that's good. I might have to include some extra stuff. So include core or actually world block map. I think we should be good there. And then YAML extended. Whoops. Okay. Include utils / YAML extended. Okay. So, and are we missing texture format config, block format? Okay. So we need to pass into block format config, which is basically just this file. And we'll have all that stuff passed in. It's the only one we care about. So we can remove that. We can remove that. We can remove this. We can remove, wait, maybe we need this one, texture format config. Nope, this is block formats. What is texture? That's something different then, I guess. I just gotta double check this real quick. Okay, yeah, this is definitely something different. Okay, so we should be good to remove this whole loop or this whole if statement. We should also be good to remove all of this. Okay. Yeah, so we're good there. And then we basically just go ahead, loop through this. I guess I technically don't need this. Maybe we'll keep it for now, but yeah. Okay, we don't need this. What was that doing? Okay, yeah, we don't need that. Okay, so if the block is not an item, then we don't care about it. So actually, we're going to change this to a true. So if the block is an item, we do care about it, and then we can go ahead and get the item texture. So let's go ahead and remove all this stuff because we don't need any of that. Okay. And then we can go ahead and get this thing. Okay, so, and then I'll remove this. We have pared this down to only the essentials. So this should get us whatever items are going to be defined in the actual game based on this configuration, right? We get this if it is an item, which is defined here, then we get the picture, which is this, and then we can actually get the file, which, how do I get the actual file? Because that's important too. I might have deleted that part. Okay, so looks like I don't get the actual file, which I don't think matters because when I load this stuff somewhere down here. Yeah, okay, so when I load this stuff, I should be building up that file path somewhere. Is it down here? Or actually, no, I think it's in Texture Packer. Okay, this is where we do it. So basically I have the file path, the configuration file path, and the output file path. And then we build up the path here. Okay, and then we just strip out the path so that it's just the name. Okay, so, I mean, this is pretty simple. I'm overcomplicating this. So instead, let's just go ahead and say std string file path equals. Also, collector of stuff, thanks for following. Good to see you. I guess I would say welcome to the epic Minecraft club. If I was trying to be Soding daily. Sam, also, nice, doing good. You forgot stream in this time, so you're a little late. Oh, that's all good. I was basically just messing around and not really doing much of anything. So we're finally just now starting to do something a little bit more interesting. Okay, so we get the file path. What is the file path? The file path is going to be assets / images / item / whatever the item name is .png. So we'll do assets / images / item. Was that right? Yep, / item plus item picture name plus .png. Okay, so that's what it should be. And then we can just basically say if I've got something in here, include core file. Okay. So then we can say if file exists or is file, which checks to see if it exists, file path. If this is a valid file, then we'll go. Otherwise, we'll log a warning or whatever just to see. So we'll just do that. And we'll say else log error could not generate item model for and then we'll pass in the file path. That way we can just make sure we don't have anything bad. And then I also need a semicolon, and we'll go ahead and we'll say if it does exist, then create item model for this file path. Just to kind of abstract that out, make it a little bit easier. Go up here, we will say static void create item model const char star, or actually I guess we could do a const stud string ref item picture. And then we'll go ahead and copy that, paste that right here. I might have these in the wrong namespace. I think I do. No, this is good. Okay. As he was, do I plan to make a huge Minecraft clone LAN party once the game is ready? That would be awesome, and it would be a great way to test things. So once I get multiplayer up to par, which I'm hoping to do next week, we'll think about that. Yeah. Maybe I'll make it so that I'll have some sort of like server that I set up or whatever too, so that we can all try it out together on stream or something. Because it would be good to actually test it on a actual server too, instead of just locally as well. But yeah, nice ticket price, $100. Nah, that's too expensive. But back to here. I did plan on doing like a LAN thing with my brothers, because they both have, my one brother has a gaming laptop and then the other one has a gaming desktop. So it'll be good to kind of like test different hardware too, all at the same time. But yeah. I wonder what ping you would have from Europe. Yeah, I'll have to do some fancy math to interpolate for long distance pings and stuff. Okay, so if we get here, let's go ahead and open up the image with STB read image, or what is it? STB image free. We've got that. Where is it? I know it's like STB something. STB, maybe it is STBI. STB read image. STB image, basic usage. Okay, STBI load. Cool, so that's what I want to do. STBI load. That works. Sam, you can send part of that code used to interpolate movement. Pretty easy. Okay, that would be cool. I probably will get to that eventually, just to sort of like add those corrections and everything for multiplayer once I start working on that again. Like I said, I have the next 2 weeks off as well, so I'm hoping to get a lot done in that time, but it's also holidays and stuff, so I don't know if I actually will have time. Hopefully, though. How's the programming going? Good. We are finally getting to opening an image. So file name is itempicture.cstring. Our X, we're going to pass in, this is width, so we'll say ref width, or I guess address of width, address of height, channels, address of channels, desired channels we'll say is 4. Okay, and then we'll say int width height channels. Oh, and I spelled width wrong. There we go. So we've got that. This should load it. Where is it loading the pixels to? It's giving me an STBI unsigned char, which I think I can just say UN8 star. Pixels equals that. Cool. Now we've got our pixels. Let's go ahead and loop through them. For X, I'll do Y. I like doing it this way. Y is less than height, Y++. For int X equals 0 until X is less than width, X++. Get the offset of our pixel. So we'll say UN8 star pixel equals pixels plus X plus Y times width, which should give us the offset, but we have to do times 4 because each pixel has 4 bytes, because I want 4 desired bytes. Okay, so that should be all good. And then we should be able to do this. Let's do something really, really simple. What we're going to do is we're going to output like a bitmap. Basically, we're just going to do like black or white based on whether it's alpha or not. That way we can just make sure that we're getting the correct pixels. And then once we get that working, we can sort of start extrapolating from there. So I'll have like a const char star temp output equals temp.png. We'll do that. And then what we're going to do is we're going to say, after we get the pixels, let's do UN8 star output pixels temp equals that allocate width times height times size of uint8, which is just 1, but it's good to have that explicit, times 4. Okay, so we're going to have that. And then what we can do is we can say if, let's also do this just to make this a little bit easier. We'll say, actually, let's do this to make it a little bit easier. Let's add a struct pixel thing up here just so that we can interpret this a little bit different. So let's say struct pixel, and then we'll have uint8 r g b a. Okay, so this is plain old data. We should be able to just cast this pointer to a pixel pointer and make our lives a little bit easier. So instead of doing that, I'm going to do that, and I'm going to do that here as well. And then we're going to cast it here, and then we're going to do that, and then we can remove that times 4. Okay, and then we can also remove times 4 here. Cool. So now we can actually just say like pixel r should work. Let's make sure this was working properly. And then what we can do is we can say pixel star output pixel equals output pixels temp plus, let's remove those parentheses, plus x plus y times width. And then we'll say output, we'll say if pixel a equals 0 for now, and then we'll just do like less than a certain threshold or whatever later. Then output pixel r equals, and actually we could just do this, equals, and then we want RGBA, so we'll just do 255, 255, 255, 255, because these are 8-bit integers. And then we'll say otherwise, we'll do black, else output pixel equals 0, 0, 0, 255. Okay. And I need a semicolon there. And we might have to just say like pixel there. Pixel there. No, you don't like that? I can't do... Oh, star pixel. Okay. Do the same thing here. Cast that just for good measure. Okay, cool. So that should give us a proper output image, and then we can go ahead, go down here, and we'll say output temp or whatever, temp output, stbi write png. Okay, so then we'll say write png, file name is output temp output, width is our width, height, components are channels, data is our output pixels, temp, and then stride is going to be size of pixel times width. Okay, that should write the image out, and then we want to free our memory, and we want to say stbi free. What are we freeing? This thing, which is pixels. Okay. And I'm freeing the wrong thing here. We should be freeing that. Okay, cool. So this should all be good. I'm going to go ahead and just put a breakpoint here so that we can see what we get for the first thing. It should just get called automatically because of the way I have everything set up. Build errors. Let's see if this works first try, though. I have pretty high confidence in this one for once. SE Woods, you forgot the stream music or just wanted silence? Well, YouTube copyright striked one of the streams. It doesn't matter since I don't have those monetized anyways, but I need to reassess what I do for streams just because of that. I don't want to get like a bunch of copyright strikes on the other channel. So I've got to take some time to reassess and then figure out. Yeah. No, Gmemory free thingy freeing the wrong thing. Is it? Output pixels temp. Yep, we allocated that. Free that. STVI free pixels. Yep, that looks right too. I think we're good. What was the error I was getting though? Declared but not defined. Create item models declared but not defined. Oh, wait, yeah, this thing. Why is this not? Oh, it's because I'm taking a block format config. Okay, so I got to also say that, and we need to pass that in, which I'm just going to pass in manually for now because it doesn't matter. So we'll say assets slash custom. Did I just start that build on accident? No, I don't think I did. Okay, slash custom slash, where is this? block formats.yaml. Okay. So we've got that. Let's go ahead and run this again. Should all work out. And we should hit that breakpoint. Nope. I think I did something bad. Okay, I'm freeing bad. Okay, maybe I am freeing the wrong thing, Voxorus. Meta Jezza. Is that supposed to be like Jazza? Because if so, I approve. You should be able to route audio into different channels and record the stream without audio channel with the music. Oh, okay. I will try that out next time because that is a good idea. Thanks for the tip. Okay. It looks like I am freeing the wrong thing. That doesn't really matter too much right now because fix it in a minute. We should have temp.png. And look at that. We've got black pixels and we got white pixels. So we can correctly detect the edges, I guess, if that's what you want to call it. So this is good because now we can figure out a way to extrapolate, or I guess extrude through that. So yeah, basically royalty-free record label. Sweet. I will open this up real quickly and save this for future use. Thank you for all the tips, guys. Okay, there we go. Yep. I will save that for later. Thank you. Okay, cool. What am I doing wrong here too? Or this, maybe? No, yeah, it's definitely this one. Pixels, it should be this thing, right? Yeah, that looks right. Do I have a... Nope, nothing there. Is it this thing that's going bad? Temp output. Temp output. Width height. Yep, that's good. Channels. I should also have this in debug mode, but it doesn't matter too much. And the name is not for Jazza. Okay. And Jomega. It's mostly electronic music they have. Gotcha. Yeah, I might do the different audio channels too, because that would be cool. What's going wrong here, though? It looks like we're failing on STPI write PNG. Is it because the image already existed? And no, that wouldn't happen because, yeah. So we do width, height, components, which are channels. I guess I should put 4 there because we are writing 4. Data, which is our output pixels temp. Stride in bytes, which is size of pixel times width. Okay. That all looks right. Let me change that. Let's see if this breaks. Nope, we get the same thing. I think it is happening when I free it. Voxorifs, you said I was freeing the wrong thing. Am I missing something here? Because I think I'm breaking on this. It says line 129. Yeah, so I'm definitely breaking on this. So something's going wrong here. But this looks like the same thing to me. I don't know why it wouldn't be happy. Oh, maybe I have a heap corruption thing. Let's switch to debug mode because I should have that enabled here. Okay, let's run this again. But there's a surprising amount of no copyright music that you can use for free online. Yeah, I that's true too. And most of it is actually pretty good too these days, which is nice. I'm not sure. I think it was when I did the lo-fi jazz or whatever, one that did get copyright struck, which is interesting because I was playing Nintendo music. And if anything, I would expect Nintendo to copyright strike something before just some lo-fi jazz stuff would get hit. But it's weird. Compiling from scratch takes a while. This isn't even from scratch too. I was also thinking about something too. The other night, do Git submodules implicitly use versions? Like, Voxorifs, UN8Ts are being allocated instead of pixel? Ah, you're right. Okay, that's what it is. So there's definitely heap corruption. I'm interested to see if my debugger will actually catch that. So we'll do this too real quickly. But yeah. So Git submodules, thanks for the catch though. That was good. I think Git submodules are implicitly versioned, which is nice because if you use them when you're doing stuff, then, for instance, what I was thinking with my game is if you clone it fresh, you should get the appropriate versions, because glfw updated, and it was really annoying because it broke one of my other things. Yep, we do get heap corruption detected. And if we hit F10, it should tell us what line and everything. Heap corruption detected, buffer overrun in memory allocated from constants.cpp line 105, which is right here. Okay, cool. So that's just good to know because it's telling me. And then if we actually look at this too, you'll see I showed this off in another stream, but it's still fun. If we copy the memory address of where this is, where are you? Can I not get your address? Locals. Oh, I have to go back up to here. Okay, so if I copy this actual address and paste it here, you will see that what we get is a bunch of this Hey Gabe stuff written, right? And it should end on an exclamation point here. That's how I detect buffer underrun, which is good. And then at the end of our allocation, it should start on an H, like H-E-Y for Hey Gabe. And this is actually too big. Oh, maybe I missed it, actually. It's probably smaller than I thought. Okay, yeah, so we've got probably something in the middle. Maybe it's up here? No, I don't know. But basically it detected it, so that's good. It might have completely overwritten like all the values I had. But yeah, that's how I detect it. And basically if this is bad, then we have buffer overrun. Yeah, I think it should be at the end of this stuff. Yeah, it looks like I just completely overwrote it. But anyways, yeah. So it detects it. That's good. Let's change that to pixel and we should be good. And it doesn't even matter too because this isn't even going to stay. But whatever. We did it. And now it's not broken. You can just paste the variable names in your memory view. Oh, that's cool. I did not know that. Okay, yep. So now we get nothing wrong. We're all good. And we get the same output, which is somewhere in here. I have too many things open. I can't. Okay, there we go. I can't remember which ones to go into anymore. Yep, cool. So we can correctly detect the edges. Okay, now the next thing. We need to interpolate these edges from a value of like 0 to width to 0 to 1. That way we can go ahead and like properly extrude them in a normalized sort of way. So that should be pretty easy. Let's go ahead and remove this stuff because we don't actually need that. And we're going to remove the output pixel thing because we don't need that as well. This is all we care about, right? And let's remove this because we don't care about this either. Okay, and we can remove that. Cool. So let's think about what we want to do here. First of all, we can get normalized coordinates. So we can say like float normalized x equals x over float un8 max, which should be good. That should normalize it from 0 to whatever to, or actually, no, that's wrong. Over float width. Okay. Yeah. So then we can also do the same thing for float normalized y, which equals float y over height. Okay. So we've got normalized x and normalized y, which is good. And then we can scale it based on how big we want the item models to be. I guess best thing is to just leave it from 0 to 1 because then we can scale it in like the shader or whatever too. So I'll just leave it as is and we will just use normalized coordinates. So then we want to create the quad, or I guess triangles. And how do we want to do this? So let's go to the drawing screen real quick. There's a few different ways we can go about this. Imagine we get our stick, right? Which is just, if I go ahead and do that, just some pixels, right? Stick looks something like that. And then goes down, right? It's just a bunch of pixels that all connect up. Okay, so how do we turn this into a 3D model? What we could do is we could just like for every single pixel, create like an actual quad, right? And then we just have 2 triangles there, and then we kind of do that all the way in. But I don't know if I really like that. What we could also do is we could just have like a center and pick the center, but that wouldn't work too. Yeah, so let's not even think about that. I'm trying to think about what the best way, because what we need to do is we basically need to extrapolate this right into 3 dimensions and kind of do something like this. That part's easy, right? Because what we do is we basically just say, okay, let's create a quad here. And we can do that fairly easily. And this would have like 2 quads. And then this would be like a quad this way. Greedy meshing implementation, is that what this would be? Because like the thing that I'm concerned about is if, I think this is probably gonna be the best way. This is gonna be the easiest way. So we'll probably just do this. We'll break it up into every single pixel, right? And then we'll just have like a set of vertices here for triangles for every single one. Right? And then we can go ahead and then I'll look into like better algorithms or whatever in the future. And then these would be the 3rd dimension. And then we could basically just do the same thing on that side, right? On the back side, we would do the same thing that we did for the front. Sam, it's the same like you render chunks. Yeah, that's what I'm saying. So basically, and if we're going to do it this way too, we don't even really need to store like UV coordinates. We could just store a color, right? We could just do the colors and then store the colors in the vertex information and then do the same thing. So yeah, I guess this is true voxels because we actually are doing just a single color per vertex. The one thing I'm concerned about is how high the vertex count might get. So like you said, Voxelros, greedy meshing might be nice so that we can like combine these 2 into one quad, just so that it's not doing that. But I don't want to think about that right now. So we're going to do the simplest approach first. Okay. So that sounds good. Okay, so how do we do this then? Trying to think. First of all, we need to get like a color embedded in here. So instead of doing this, we'll say vec4, and this could actually be a U8 vec4, which will be 32 bits, which we can just like pass one integer to the GPU, which will be nice, and then we can just sort of reverse it and everything from there. So we'll do that. Maybe. I don't know. We'll think about it. And so that part should be easy, right? So for each vertex, which basically for each one of these, we're going to generate how many faces? I guess up to 6, depending on which faces we actually need to generate, right? And this is actually interesting too, because if the alpha is 0, we don't actually want to do it right here. We only want to do it if this alpha is 0. Yeah, okay, so this is exactly like the chunk generation, right? Okay, so this should actually be pretty easy, right? Because basically we want to do it if the alpha is not 0 and one of the surrounding faces is 0, which in this case we just have 4 faces. 1, 2, 3, yeah, left, right, top, bottom, right? Those are the only 4 we've got. So then I can go I normals to cardinal directions, which should be, yeah, up, down, left, right. Okay, cool. So then we can do this to sort of go in each direction. So we can say for glm vec2 ref, and I guess that could be const. Whoops. Direction and iNormals to cardinal directions. We'll do this, and then we will go through here. And we'll simply say, and then also I should create this vector real quickly because that's going to be important. So we'll create that here as well. And then this will be our vertices. Okay, so then we'll go through each of the cardinal directions. And I guess I should just do this. Yeah, and then if our pixels alpha is not 0, we should only do this if the pixels alpha is not 0. Okay, so we'll do that here. If it's not 0, we go through each of the cardinal directions, and then we'll say if the next one is 0, so we'll say neighbor pixel. Neighbor pixel equals, and actually we should do another check too. We should say if, well actually, okay, we'll do that in here. So we'll do this. We'll do this. We'll say if glm vec2 xy plus direction. So I guess this is the neighbor pixel position. Let's do this real quickly too. So we'll say vec2 pixel pose equals that. And then we'll say neighbor pose right here equals pixel pose plus direction. And then we can say if the neighbor's position is less than our width and y is less than the height, and x is greater than or equal to 0, and the y is greater than or equal to 0. If all of that is true, then the neighbor is inside. So that's good. We can do that. That should be that. Okay, and then we can say neighbor pixel is whatever that position is, right? Okay, so then we would say neighbor pixel is something like this, which is going to take in that and that. Okay. And we should cast those. This should actually be like a U vec2 or something, right? Or an I vec2. Yeah, let's change that up real quickly too. So we'll do that, that, and that. Okay, cool. So now we're good. We're getting the neighbor pixels. All that's good. We can remove that. And I think this is what we want. So this should correctly detect the edges. I guess we probably should have left that PNG thing because it would be useful now to see if we're only getting the edges. But this is good enough for now. I'm trying to think too, because this should be all we need. Well, we have to worry about edges, but we also have to worry about interior pixels too. So I might actually need to do that. Do you spot a pull-up bar in the door behind you? Yes, you do, but it is used very infrequently. So got it a long time ago. And every now and then I'll think that I want to start working out again and use it a little bit, but hasn't been used in quite a few months. Okay, so what I'm thinking of real quickly too is we also need interior pixels to be added to this, right? We also need something like if we had 2 more pixels here. Actually, we'll do 3 more pixels, kind of like this, right? If we have a 3x3 here, and I'm using my mouse right now, which is why it's so horrible. Okay, if we have a 3x3 here, we basically want to make sure that we add this to our vertices as well, because it's technically showing on the z-axis. So we need to make sure that we check that. So if the pixel around it is alpha, or we have a pixel on every side. Actually, I guess we're just basically checking if the pixel is, well, yeah, if the pixel has a pixel on every side, then we just want to make sure that we don't extrude it in the Z direction, right? So this means don't extrude in the Z direction. And then if it has any alpha, this means do extrude it in the Z direction. So that's what we need to sort of keep in mind. Okay, so this is if we don't have a pixel in the Z direction, right? Let me think about this. Yep. Okay, so this is basically saying if our pixel has color and the neighbor does not have color. Yeah, so then we can say if neighbor pixel, which I thought I had. Did I delete that on accident? Oh, I did. Okay. Yeah, and the neighbor pixel doesn't have color. doesn't have alpha, or does have no alpha. Yep. So just got to think about this for a minute. Also, I'm probably going to drop off just for a second here so I can think about this. So I'll be right back and then hopefully come back fresh, like 3 or 4 minutes maybe. Okay, guys, so I will be right back. Think about this real quick, and then I think we can finish this off. All right. I think I know what we should do. Also, no partying while I'm away. That's not cool. You guys should party when I'm here, if anything. Okay, I think I've got an idea of what we need to do. So basically, let's go back to here. Basically, we need to generate this face regardless, right? So if a pixel is non-transparent, we need to generate this face and the back face regardless. The only thing we need to worry about is, do we extrude along the z-axis and generate a face here? If we need to, and we only need to do that if we're on the border. So like if the picture is this big, right, something like that, and there's no pixel here, then we need to extrude along the z-axis. Or if this side is transparent, then we need to extrude along that axis for that face. So that's like the only thing that we really have to worry about. So basically, when we're going through, we generate the front and back faces of any opaque pixels regardless. And then we need to say, go through each of the neighbor sides, and we need to figure out which axes we need to extrude along the Z, right? So that I set this to false originally, and if the neighbor's pixel is 0, or if that pixel is out of bounds, we say we need to extrude that Z face in that direction. I think that's what we want. I think that should be good. So, and then that will basically mean I can just go like, oh, which direction was that? Well, I can just say I normals 2, cardinal directions I, and I think, yeah, that should get us like which side that was, like left, up, right, or bottom. And we can add that to our pixel position and then just extrude that Z backwards. Okay, so I think this is what we'll do. I think that's good. Also, last week, I know I wasn't streaming, so quick story and stuff too, because this was insane. Partly, I didn't stream just because I wanted to take like a day off because I was tired and stuff. But also that night, I was woken up at like 3:30 in the morning because there was just like these insane storms. I don't know if you guys saw anything on the news or whatever, but all across Middle Tennessee and Kentucky in America, like last week on Friday, at about 3 in the morning, 4 in the morning, there was like 5 or 6 tornadoes, pretty much across the whole Southwest. I think there was Southeast. There was like 36 tornadoes. I remember seeing that somewhere, but there was really bad storms. And I woke up at like 3:30 in the morning, and I'm on the top floor of my apartment complex. So like I can't really go downstairs or anything because my neighbors are down there. And it's like, you're supposed to go to a basement in a tornado. So I was like, okay, I don't know what I should do. So I just sort of went to my closet and was like, I guess I'll just hang out in here for like an hour and watch the weather. So I was hanging out in my closet just like, I'm going to die. I didn't. So that's good, right? But yeah, that's what you get for living in Tornado Alley. But funny thing is, I'm not in Tornado Alley. I'm in Middle Tennessee, which typically isn't that bad. Like we may get a few tornadoes every now and then, but it was just, it was insane. So yeah. Glad we don't have tornadoes in Norway. Yeah, tornadoes are not fun. And SE was, does cross product of XY give Z, or am I remembering wrong? No, you're right. Yep. So like you do the finger thing, right? Where you have like your axis. And if you cross this and this, you get this, your thumb. So, yep. Luthon, good to see you okay. Thanks. Yeah. A lot of people weren't okay. So it is really good that nothing happened here and stuff. So I've been quite lucky for the past few times we've had tornadoes because, yeah, it's not good. But middle of the U.S. is the place where something like 90% of all tornadoes. That's true. But I used to live in Florida, and in Florida, you have hurricanes. So like, I remember when I was way younger, we had this Hurricane Charlie, which was like a category 5, which is like one of the highest categories you can get. And we stayed, and the eye of the hurricane passed over our house, which that was insane too. Like it was just storming. One of our windows was broken because like our part of our fence had knocked into the window because it got picked up and thrown at the window. And so, you know, you're in this horrible storm and stuff. And then all of a sudden it just all stopped. And so I remember seeing some of my neighbors, they like went out onto the street and stuff and were like looking around and everything because we were in the eye, which is the center where there's nothing happening. And that lasted for like 20, 30 minutes. And then all of a sudden you're just getting hit by these horrible storms again. So Weather is yeah, weather is fun, right? We lived through that too. All we had was a broken window too, which is insane. Yeah, but I was young too, so I don't remember it as well as like the other night. But yeah. Okay, so yeah, and that's what you were thinking. Finger roll. Yep. Mother Nature does not. I agree. Okay. We've got all this set up though. We should be able to sort of work with what we got here. I'm going to do the front and back faces first, and then we'll do the extruding on the Z-axis afterwards, because I think the front and back faces will be pretty easy to sort of add. So how do we want to do this? Add tornadoes to the clone. That's actually a good idea. I think it'd be cool to have weather patterns and like earthquakes, or maybe even just stuff like Terraria has, where like you get asteroid just in the middle of your world. So you're playing and then all of a sudden your world's ruined because an asteroid hit your whole build. Might be fun. Might annoy people too. So, or I don't know. I used to play Roblox when I was younger, and I don't know if you guys ever played. There was one, it was like, it would be weather patterns. And so there was tornadoes, and it would just start picking everyone up and like flinging them everywhere. And that was always fun. So like maybe having blocks fly around when a tornado comes through. Make it hell living in the virtual world. Yeah. Actually, I do want to have hell in the virtual world, right? If you dig down far enough, I do like how Terraria has that, because that always made a lot more sense to me than going through a portal to get to the nether. So, okay. Anyways, this should be pretty easy. Generate front and back faces. So we've basically got the center of the pixel. We have the normalized coordinates, which I'm actually going to take those out to here. So we got normalized X and normalized Y. And how big is each of the pixels? Well, the pixels are basically just 1 over pixel is how big each one should be. So we can say float normalized width equals 1 over width. And then we can say float normalized. And maybe we should call this normalized pixel height, and pixel width equals 1 over, just so that's clear, height. Let's call that pix width. Okay, cool. So now we got the width and the height. We've got the X and the Y. And actually, we probably want half, because that's simpler. So we'll do this, and then we'll do over 2. That way we can extrude like half in all the directions, because that's normally what we'll have to do more often than having to go a full unit. So we've got that. What we can do is we can say vertex is what I called it, item vertex. Vertex dot position dot x equals normalized x plus what the heck did I call that? I can't even think now. Half the width. Okay, so we're gonna do like half the width, and then we're gonna say position dot y equals normalized y plus half the height. And we can abstract this into a loop. So we need to generate for top, bottom, left, right. So we can say for const glm ivec2 ref direction and cardinal directions, inormals 2. Cardinal directions. We'll go through all those. And what we'll do is we'll say add half the width times. Or actually, I guess what we should do is we should just change this to be like a glm vec2 normalized pix size equals vec2, the half width and the half height. So we'll do that, and we'll do that. Okay, so we do that, and then what we can do is we can say the x position is just the direction. So the x position plus the direction times our half size, which is this. And I think that should work. So that should abstract it pretty nicely and just make it easier for us. And let's see. Times, no operand matches for ivec2 and vec2. Oh, we need to just make that, which should be fine. What is wrong with this? Oh, and then we also need the x position. So this is basically just like the offset, I guess, right? So this is the, or actually we could just do this, right? Let's just do that, and we can just say that I'll abstract that into a variable too in a minute. So let's just call this current pose. Okay, we'll do that. And then we can say that is the current position plus the direction times all that stuff. What's wrong with this? This expects a vec3. Yes, that's important too. So what we can do is let's change all these to vec3s because that's just better. So make that a vec3. There we go. Make this a vec3 dot x dot y 0. Make this a vec3, which we're going to say this is 0. Okay, cool. So that should be good. And then what is that? Vec3 and vec2. We got vec3 there. We've got vec2 there. That should be vec3. Okay, there we go. So we should basically just get the position plus the direction times the pixel size. And if we loop through all the cardinal directions, that should get us every single vertex. And then what do we want to do? We basically just want to build up a quad from that. So 2 triangles. So we can basically just get all the vertices, I guess. So we'll just say item vertex because I'm going to do GL draw arrays for this stuff for now. Vertices, we've got 4 vertices for each quad. So we'll do this, and then we'll just say I equals 0, I plus plus, and then we can just say vertices I equals that dot position. Cool. So we'll do that, and then color is what this should be up here. Yeah, let's change that to a color. Okay, and then we can set the color to whatever color this pixel is, which we have right here. So we can just say, and then vertices I dot color equals whatever our current color is, which is this pixel. So we can say glm uvec8 or u8 vec4. And then we basically just want to pass it pixel r g B, and A. And that should be good. Okay, so that should generate the back and front faces. We'll have to make sure this is actually working properly. Essie Woods, just before this stream, you were watching Cherno making a game in his engine. The engine is high-tech for sure. Yeah, I just saw that release today too. I'm going to have to watch that in a little bit. But, yep. It's cool seeing the engine take shape too. And also, another engine that I really like following is R Machinery. Voxelriffs, you might actually really like this too, because they're doing it where all the APIs are C99, I think. So only C99 headers, but the engine looks insane, and they have a lot of cool tricks that you can read about here. I think I've already talked to you about this, Voxelriffs, but it's awesome. And they just started doing networking, which is perfect timing, because now I can follow their networking and sort of steal what they're doing. They only have part 1 out right now, though, in October, so hopefully they'll release more soon. But yeah. Another cool thing, R Machinery. Check that out if you guys want. Anyways, so we generate the back and front pixels regardless. So we're going to go ahead and generate 4 vertices, and then we want to generate the quads, push quads back, right? So what we can do is we can say like, Jomega, with C99, you do lose nice templates. Well, yeah, so their thing is they only use C99 headers. That way it's like cross-platform and everything, but the implementation can be C++. And so they do allow templates and stuff inside of in certain implementation areas to make their debugging stuff a little bit easier, or I guess their development easier. It's a really cool concept. And the reason they do that is because their whole thing, like R Machinery, little machines working together. And so basically it's just a bunch of DLLs and everything is like hot swappable. Like every single component of the engine. It's really cool. So yeah. Essie Woods, can you use any language for scripting? Yeah, I guess you could. Some languages are more difficult than others. So yeah, I think I'm going to use Lua whenever I add scripting to this because it's probably the simplest way to go. Okay, anyways, though, we need to add these to our vertices. So we can say vertices.push. Where is it? Oh, this is our, what should we call this? Quad vert. Let's just call it that because I have vertices up here, which is our vector. So we'll say vertices dot push. We want to do quad verts 0, then 1, then 2, and then we'll do 0. So that's the triangle 1, and then we'll do 2 and 3. So that's triangle 1, and so that's for the front face. And then we can do back face pretty simply as well. So we'll do this, and this should be creating copies too. So that's good. So then what we can do is we can say for int I equals 0 till I is less than quad verts, or I guess just 4, because that's not an array. Quad verts I dot z, or position dot z minus equals normalized pixel half width. They should be the same because a pixel is 1 by 1, and I don't think these are all square pictures too, so they should be the same. To do, ensure width and height are always, actually let's just add an assert, easiest way to do this. So we can just say like glogger assert that equals that, because if it doesn't, we'll get some weird looking stuff. All item pictures must be square. Okay, cool. So that should just ensure that everything should work correctly. So yeah, we basically just subtract that, and then we push all those back too. So that should be front face and back face. We'll worry about Z faces for things that we need to do later. I just want to make sure this is working properly though. So let's go ahead and do this, and then I'm going to go ahead and break here, because I just want to test it out with 1 and see if it's working. So I think this is going to get stick is what the first thing we get, which, yeah, if we look in here, we get stick. So if we draw the sticks model, we should be able to see it. Basically what's going to happen. So what I'm going to do is, let's go to my renderer, because I actually might have to change this up a little bit. Okay, so we have this draw textured cube. I could have sworn I had a way to just draw like arbitrary shapes too though. Like just draw a triangle or something. I might have, it might just be in the implementation. So I might expose that so that we can do more fancy stuff. Let me look up here real quickly. Yeah, okay, so I have draw textured triangle. 2D and 3D. And basically you can either draw it with a texture or without a texture. You don't actually have to pass a texture in. And if you don't pass a texture, I think it just uses, nope, there's no color passed in. Okay, so maybe a texture is required. Okay, so I might just add an extra thing in here. We'll have like a void draw model. And this will just take in a bunch of vertices, which I've defined here. So let's actually move this. It's actually up here. Let's move this into here. And then I can make this more full featured later if I want to. This will take in, we'll just call this model vertex. Actually, we could call this a voxel vertex, because that's what this is. It's just a position and a color. Okay, so we'll take that. And then what we'll do is we will say, take in const glm vec3, position, scale, and I guess rotation. But we're only going to rotate on the z-axis. Yeah, I think we're only going to support rotation on the z-axis. Okay, so we'll do that, and then we will take in a voxel vertex thing. We'll just take in a pointer there. Vertices, and then we'll say int vertices length. Okay, so that should be good, and then we can just add these to our batches. This is not going to be efficient, I know that, but it's going to work for now, and I can experiment with it, and then I can change this to use like instancing and stuff later, because right now I just want to make sure it works. So let's go down here. What do I call this? I called this draw 3D model. Let's copy that. Let's go down 3D functions. Okay, so we've got all this stuff, and this should actually be pretty easy to do. We can just paste that there. Let me move it up so that it reflects where it actually is. That's good. Okay, so we need to say if we don't have enough room in the current batch. So plus, this is also wasteful of length, but actually, you know, I probably don't have to do this. I could probably just say for int I equals 0 until I is less than vertices length, I plus plus. And what we'll do is we'll add each vertex as we go through. Sort of like what we're doing here. Except in this case, we're going to be adding something down here. Okay, this is what we're going to be doing. Not render vertex 2D though, render vertex 3D. Okay, cool. And so we can just set the texture slot to 0, I believe. Nope, can we? I don't know. I got to check this real quickly. So texture slot, texture chords. Okay, I don't think we can. I'll have to modify this a little bit more in the future too. But for now, yeah. Let me check the chat real quickly. You think the Cherno uses C#? Yeah, for scripting, I think Cherno is using C#. And Voxriffs, just remembered, yesterday you wrote your 10th OpenGL render, and looking back, the difference in API and simplicity is astounding. Nice. Yeah. Okay, so I think what we're going to do is we're just going to have like another set of batches here because that's going to be the easiest way to do this. So we're going to have a static. Oh, and I only have one batch too. That's not very good. Oh, actually, I don't think that matters. Yeah. Okay, so we'll just do this, a batch of voxel vertex batch 3D voxels. Okay, so basically we just have one batch, and every time this fills up, we flush it. And then that draws everything, and then it, yeah, continues on. And then it starts over, it clears it, and then it goes and does that stuff again. So that's sort of the concept we'll use. If we go back down to where we had this thing now. Yep. Draw 3D model. Yeah, so then we can basically just say if we're greater than the vertices, we'll say flush voxel batches. And we'll add that in a minute. But for now, what we want to do is we want to add it to our voxel batch thing. So we've got to do something similar to what I've got somewhere down here. Okay. Okay, so we got to do something similar to this. There we go. I just had to find out what calls I need to do, function calls and stuff. So we will go ahead and say render vertex 3D. This is actually going to be voxel vertex v.position equals, and actually, I guess we technically have the thing just right here. So we don't even have to do that. We can just say voxel batch 3D voxels dot add vertices I. And that should be good. And then what we'll do here is we'll say if that number of vertices is greater or equal to batch max batch size, and then we flush. Okay, cool. So that should be good. And then we just need to write that flush thing. So just copy this and it'll be very similar. So this basically just sets up all the stuff we need. Void flush, what did I call it? I can't even remember now. I think I called it flush voxel batches. I can't go back to it. Okay, where'd it go? There we go. Flush voxel batches. Okay, cool. So we'll go that. Call it that. Okay, and then this is going to be that. So we disable face culling. I don't think I want to do that, do I? Yeah, I don't think I want to disable. Oh, this is for, okay, yeah, I can get rid of that. So get rid of all that stuff. So we enable face culling. That's good. And then we're going to say add a new shader. We'll bind that, bind. Then we'll go through, we don't have any textures to worry about because these are voxels. We don't have to worry about that. And then we can just do this. And this is +1 draw call. Cool. So that should be good. Yeah, so then we just need a shader. I promise we're going to get there in a minute. We are almost there. Static shader that. Where do we go and build our shader stuff? We build that up somewhere here. There we go. So we'll say shader, compile. We'll add this in a minute. Voxel shader.glsl. Okay. We also need to initialize our vertex attribute stuff for this thing. So we'll do that. We'll say batch 3D voxels. And this has, what does this look like? Position, vec3, color, vec4. So we'll just say 0, 3, position. That's good. And then attribute location 1 is 1 uint. Actually, this works perfectly. Cool. And then we'll just say color. And what is that saying? Did I call that wrong? Color. Yeah, that's right. Oh, this is wrong. Okay, so this should be render or voxel vertex. Okay, cool. So we should be good here. We have a shader. Let's add a shader. It's going to be a very simple shader. So we're going to call this, I think I called it voxel shader. And I just spelled that wrong. Okay, let's go ahead and fix that real quickly. Rename this. That's better. Okay, cool. Let me check chat real quick. What is today's plans, Gabe? Chopping trees, going for a hike, or just relaxing? Those are the alternatives. I don't want to chop trees today. That's not fun. Relaxing at home is underrated. It really is. I do not spend enough time actually just relaxing. But it is actually my youngest sister's birthday today. So I'm going to be going and seeing her. And we're doing like family stuff for that. So yeah. Those are the plans. And then relaxing the rest of the day. So yeah. Let's go ahead. I'm going to copy this, paste it. That's all good. Get rid of a lot of this stuff because we don't really care about all that stuff. Get rid of all this stuff too. Except for that. And we can get rid of that. And we can do this. And we're basically good. View times projection times view times, and then this will be vec3, a position, times vec4, a position. Okay, cool. So we can do that. This is a color, and then we'll have like some sort of color thing. For now, we're just gonna output whatever, and we can fix that later. So we'll say out vec4, f color, and we'll just put that to 1 for now, and we'll actually extract that information in a minute. Let's go ahead and just say in vec4 f color, get rid of all this stuff, and then we can go ahead and say frag color equals f color. Okay, and we should be good. Yep, I think this is all good. Cool, we're good. Simple shader, doesn't need to be too complicated, and I think we're fine. Okay, so we've got all that, and then the flush batches should be good now too. Yes, that looks good. Change that. And I think we're good. Cool. We just need to call this now when we want to draw a model. Right? I just abstracted this in something called draw 3D model. So let's go ahead into our player controller. And we can do this in here. I think I have constants in here already, but just in case, util/constants. Okay. Also, Andrew 30, how's it going? Good to see you. Oh, I thought that said welcome to the Steam for a second, Langors. It does say stream. I just can't read today. Okay, so let's go ahead and draw a stick in front of the player, which should be pretty easy. What I'm going to do is inside of constants.h, we've got nothing to get models. So what we'll do is we'll say return stood vector. So we can just return an item vertex pointer. This should be pretty stable. I'm not changing it after it initializes. So we can just say item vertex pointer, and we actually need to return how long it is too. So let's just make a structure real quickly to model this, and then we can fix this stuff later. Item vertex, and actually let's change this too. This shouldn't be item vertex anymore. This should actually be whatever we have in our render. So we'll say include that this should be voxel vertex. Okay, so just make sure that's all good, and we shouldn't really have any problems. Oh, we never set the vertices too, so that's going to be important too. Okay, so we got all that. After we set all this stuff too, and I don't need this as well. Yeah, we actually need to set that as well. We have the item picture name here, so we can just say item models, item picture equals vertices. Okay, and what's wrong with this? Stood string stood vector, that should be fine, right? Am I doing that right? So string to a vector of vertices. Thank you, Langors, too, for being on that. Dang, okay, lots of, yeah. Okay, as you would see ya. Thank you for coming to the stream. I think we're just about here too, so let's see. Why is this not happy? Do I have to just say like insert or .add, push, in place? No, I think I'll just do this. So this is a const string ref. That should be fine. Do I have to like... Yeah, I didn't think that would work. Why is it not happy with this? This is weird. So it's a string to a vector. So I'm giving it the picture, which is a string. And it should go to a vector of vertices, which is a vector of vertices. Oh, did I fix this? Yeah. Okay, yeah. This is just weird. What if I did something like item models stick? Does this work? No, it doesn't like that either. This is strange. Stood string. I can't tell if this is Visual Studio just being stupid or if this is an actual problem. So this is stood string to stood vector. And this is an unordered flat map, which is just a map, hash map. Let me look up. It should just model exactly what you would do in the standard library, which I'm pretty sure is this. Let's see. What do we have? We have these operators. We don't have bracket operators for some reason. That's weird. Do we not have bracket operators? Did I do this right? Okay, so we've got unordered. Oh, this is const. That's why we don't have bracket operators. Okay, so now that that's not const, that's fine. We're actually adding it to the map. And what I wanted to do was have something like item vertex star vertices and then like int vertices length. Okay. That's better. And we'll have like a struct, or this should be voxel vertex. Okay, just forward declare that. Okay, so, and let's also go ahead and change this to be, instead of that, we'll have this link to a model, which, yeah, okay, we're just gonna have that link to that. I think that's better. Okay, so then we can go ahead and say, create model, that's static. Okay, right here, we'll say void, or actually I guess model, const model ref, get model, const stood string, ref, name, item name. And then we'll actually call this get item model. And this will return item models, item name. Okay. Actually, I guess we need to do like stood vector, const stood vector, voxel vertex, ref. If I can do this, okay, item models, or I guess item model, or vertices equals item models, item name. And then we can return a copy of this actually. So I'll just have this return a model object, and this will return item vertices.data and length or size. Okay. And it doesn't like this. Oh, let's just make that a const star real quickly. And we're good. What's wrong with this? Cool, we're good. So that should be good. We can now get the item model. Copy that, paste it down here. And now we should be able to draw it. So if we go into the player controller, like I was about to do, we can go ahead and just say static model stick. And if we go, and I already did that, that's good. Inside of init, we can just say stick equals vertices get item model stick. And this should all just work, okay? And then when we go and draw, we can go and draw it wherever we're pointing at for now. I think I have this somewhere in here. Yeah, okay. So what we'll do is, for now, we'll just draw it wherever we're pointing. I kind of had something here to do that before. So we'll say, yeah, you can see to do clean this garbage up. Okay. So yeah, what we'll do here is we'll say res.point. I'm trying to see where I want to draw this. Yeah, we'll use this. Okay. Plus that, I guess. Okay, so we'll say render, draw 3D model. Position is that. Scale is just going to be 1. And it's not actually going to do anything anyways. And rotation doesn't actually do anything anyways right now either. We'll fix that. Vertices is going to be stick.vertices. Vertices length is stick.vertices length. And we should make that a const star because we're not actually going to modify anything here. So let's make that const. And same thing in here. Make that const. Okay, and I think that should be it. That was a lot of stuff. If this works, I will be surprised. So yeah, we'll see what happens. Like if this works first try, I will be very, very surprised because I added shaders, dynamic model generation, all that stuff. It's all pretty simple, but I know there's probably mistakes. Yeah, there's definitely mistakes in places. Okay, so it's going to take a while to start. Actually, that was pretty quick for how long I thought it would be. So let's see what happens when we draw. Are we just going to crash once we start trying to draw it? This is taking a while. Oh, it's because I'm in debug mode. Okay. Well, it's not crashing, so that's good. Also, I can't set the time for some reason. That's weird. Am I doing this wrong? Huh. I don't know how I broke that, but that's not good. I can't see anything. Let me see if I make this bigger. Is it a little bit easier to see? No. I also don't see a stick being drawn anywhere, so that's also not good. Let's go ahead and exit. If I comment this out, does that make the lighting work again? Because if it does, then something is definitely wrong. Oh, and I know why it's not drawing too, because we actually have to flush those batches at the end of the... Okay, we'll fix that in a minute too. Okay, what's this saying now? Oh, okay. We corrupted the world. Let's go ahead and delete that. I'm actually going to add this back in because I think I know what's wrong here. If we go to the render, we just need to make sure that if a batch doesn't fill up at the end, that we actually flush all of those batches. Yep, so when we render, we need to just make sure we say flush those, and we should be good. Okay, let's try this again. Nope. Oh, I need to for declare this, which we can put in here. Void that. Okay, and we should be good. Yeah, cool. So let's try this again. If we still don't see it, I don't know what's wrong now though. And now we got to wait for it to compile real quickly. Okay. Fingers crossed though, we get like the stick shown without the edges, and that would be awesome. And does Minecraft too, I think they usually just do like black on the edges, or do they actually like use the pixels color when it's extruding along the z-axis? Don't know for sure which they do. I think they use the pixels color, but not completely sure. Are instancing and batching mutually exclusive? Yes. I mean, technically you could use GL multi-draw to do like instanced batches. It's sort of similar, I guess. It's kind of different. I don't know. But for the most part, they are exclusively mutual or mutually exclusive. Okay, lighting still isn't working. Do I see anything being drawn there? I don't think I do. And I can't see anything because I can't change the lighting. Okay, let's save and exit real quickly. And it's the pixels color. Okay, cool. Let's go back into here, comment this out. And inside of our render, comment this out and see if we can change the lighting now. Which if we can, that's just, I don't know why that would break the lighting, but yeah. The only thing I could guess is like maybe I'm not binding the shader or something. Okay, loading. And now you guys can see too how much faster release mode is than debug mode. Okay, so if I go and set time. Okay, it's still not working. I don't know why we can't do lighting. I bet you it's because of like that retest late thing I have. Yeah, I'm guessing that's probably what it is. Let's go into chunk.cpp real quickly. Comment this out so that I can actually see what's going on. Okay. So now I think we should be good. And then we can start debugging and figuring out what's wrong and why we're not seeing our stick. Also, the way I'm doing the loading screen here is basically I just launch a thread to keep track of, not stick, set time. Okay, yeah, so it was that. Basically what I do is I launch a thread to keep track of how many of the commands I've sent to the Vertex, or I mean the multi-threaded chunk manager thing, and then it basically just returns how many are left or whatever for the progress thing, which is why it's kind of inaccurate, but that's fine. Okay, I definitely don't see any 3D models popping up where I'm pointing. Oh, and that's also, I commented that out, didn't I? So of course I'm not going to see it. Let's go ahead and comment it back in real quickly. Okay, so if we draw a 3D model and then inside of here, we make sure to flush those batches. The next step is to just like hard code some stuff in the shader to make sure we're actually getting vertices. And if we're not, oh, actually, you know what it is. I know exactly what it is already, or at least what it probably is. We're not transforming the vertices. So when we go and draw a 3D model inside of here, yeah, we're not transforming these vertices. So what we want to do is we want to add vertex. We can say like voxel vertex equals vertices I, and then we can say vertex.position plus equals position. Okay. Transform it. That would be nice. Okay, and then we can say vertex. All right, and then we can add the scale and the rotation in the future too. Let's see if this works. So it might have actually been drawing it just in a different part of the world. But if that's the only bug, I'll be pretty happy with that, because usually it's a lot more that I'm trying to fix. And my coffee is going to be completely cold now. Yeah, cold coffee isn't good. Okay, no. So it still don't see anything. We are transforming it now, though. Did I uncomment the right line of code? Okay, yep. So I'm definitely trying to draw it, and I'm drawing it at where we hit plus the normal plus what is this vertical offset? It's 0, so that doesn't even matter. Oh, yeah, I know what that is now. We don't really need that. Saying with a scale of 1, I pass it the vertices. Let's put a breakpoint in here and just see what we get for our vertices and make sure they sound right. Not sure if they will, but that's a good step to take, I guess. And I guess it's also good to see if we're hitting that. We should hit it as soon as we like land on a block. Sam check. You can check it in RenderDoc. Oh, to see if it's rendering and where. That's a good idea too. I just want to kind of verify my assumptions though about these before I go to something like that. Okay, yeah, see, these are null. So it's a good thing I checked this first. It's just getting null there. At least it's returning 0 there as well. That's good. Why is the stick null? Let's go up here and see if we're getting something weird here. Oh yeah, I agree. RenderDoc is good, but like first, it's good to check these types of things because it's usually something simpler like this. So yeah, so we get something here. What's item models? What do we have? We have 0 things in item models. Why do we have 0 things here? Do we? Yeah, it looks like, okay, so size is 0. So we're not getting any models. Are we hitting this? Because if we are, we should be adding stuff. And are we getting any errors? That's probably a good thing. Nope, we're not. Okay, let's check that. Viteria Stream, what program am I using? This editor is Visual Studio. The thing that I keep launching is Minecraft clone that I'm coding. So, yep. We are hitting this too. Item models is 0 size. What is the size right now? That's all I want to see. Let's just do this. Watch item models dot size. Why can't you just tell me what the size is? That's all I want to see. Let's do this. See if that works. No, it just keeps saying equal to. I don't want to say C equal to. Okay, here we go. Number elements, 0. Step over that. 1. Okay, that's good. Okay, so that should have one image, one thing. And then we go into here. We say that. Okay, we still have one element. That's good. We should have more though. And it's weird that it's 1 now, but it wasn't 1 before. If we do that, 2. Okay, so it basically just generated something. Yeah. What's going on here? This is weird. So we do this. We say create item model if we read this, which goes ahead and does all this stuff. which this should get hit multiple times. Oh, you know what it is? It's because, so I have is item is true here. Okay, no, yeah, I have it true here as well. So we should get hit like a few times there. It's weird that we're only hitting it once. Let's put a breakpoint in here too. See what's happening. Shafia has, how is multiplayer feature going? Still haven't added much to it yet. So I've got to work on that. I plan on doing that this upcoming week and just like really, I want to get a few things just completely done. And then I plan on moving this to be closed source. I'll still stream everything. So you guys can still watch me stream and everything, but code's going to be closed source pretty soon. And then moving it to like my own game and not just a Minecraft clone. So yeah. So, but in answer to your question, multiplayer should be, I want it to be done by the end of next week and like working super solid, as well as like all the other core features of the game. And I'll be happy if that's good. So yeah. Okay, so we hit this once. This is an item model. And what do we see here? We see we get size is 0. We hit that, size is 1. Okay, we step out of this. Oh, and then we break. That's why we're only getting one thing. Let's actually build all of them. How did I miss that? Okay. Yeah, so that might be why we were getting null there. Okay, so we hit this once. What is this too? This is stick.png. Oh, and it's using the wrong thing here too. That's another thing I should fix. Item picture. Oh, yeah. Okay, let's actually pass just the item name as well. So let's go ahead and create item file path and item picture name, because that'll be what we want to name it by. So let's say const string ref item name. Okay, and then we can do that. Okay, and we have to add that up here too. Const string ref that. Cool. So now I think we should be good, and then we should see if we're actually working or not. And I should make a default to returning null and 0 if it doesn't exist, and then logging an error. Okay, so we get stick, wooden pickaxe, cool. So then when we go here, this should be F11. So we go, okay, cool. So we're getting 1,464 vertices. Dang. Is that a lot of vertices? That feels like a lot of vertices. I guess it's technically not too much, but yeah, that's why I kind of want to consider doing greedy meshing or something, because this feels like too much. It shouldn't be that expensive for a simple stick. But that sounds right, at least. Let's see if we can actually see a stick when we draw things. Okay, so then we get this. I think this is fine now, because this should be, yep, we get vertices there. We get 1,464. Cool. Let's hit continue. Okay. It's lagging bad. This is why we need instancing and not that. Yeah, I'm at 30 FPS, so that's not good. And I still don't see it too. Yeah, so nothing is drawing still too, which isn't good. Let's do, I added another thing too, which is nice. So let's do this, and I might actually, I'm not sure if this is going to work. So I added a reload shaders function too that lets you just reload shaders really quickly. But I don't think I'm going to reload the shader I just wrote. Yeah, okay, so I have something in here called reload shaders. Yeah, and it basically just does all this. But I might need to add that to our render so that I actually reload all shaders. Yeah, okay. So let's go to render.h. That way we can hot swap shaders in and out so that I can test different things and it's easy. So let's go ahead, add this. This will be very simple. Just go up here where I added that, which I think is like right here. Yeah, okay. So we'll add that right here. And then this will basically just grab all that stuff. Oh, I also have to add batch 3D voxels shader dot free. Okay, I also have to add that. What's wrong with this? Free. Yes, it does. You're just broken. Okay, so we're basically going to do all of that. Oh, dot destroy. That's what it should be. Whoops. It was telling the truth. Okay, destroy. Copy these four. We can go here. Do that. And then we can say, then after we destroy them, we just recompile them. Okay, cool. So do that. That's good. And then we can go into our scene, which is where this happens. Okay, and this just does that. And then I can just literally say in here, render reload shaders. Okay, cool. So now we should be able to reload those shaders just so that we can easily swap them out at runtime. Render doc for the win. Yeah, I'm going to check that out in a minute too. That's a good idea. I'm not sure if that vertex data is right too. I probably should have taken a deeper look at it. Okay, let's see if this does something. I do like having the ability to reload shaders really quickly though. So I think it's still worth adding that in, you know. Okay, cool. So that's good. Set time 1000. Okay, escape that. Let's go and modify this guy. We're just gonna say frag color. I mean, frag color should equal white right now anyways, but let's just default it to that instead. Okay, so then if we go ahead and say reload shaders, should reload them. I still don't, wait. Something weird's happening there. They're like flickering. Yeah, I don't know why it's flickering white like that. That's kind of weird. I still don't see anything though. So maybe we do render doc. Let's add this in. I have it launched over here. Let's go ahead and just exit that. Okay, so we got this here. Let's go ahead and grab that. Change the asset path or whatever, debug path to this. Okay, and then we'll launch. We'll see what happens. By the way, render doc has dark theming options. Oh, cool. I will change that too then at some point. And lazy 008. Hi, Mark. Is that a reference to the room? Because if it is, I approve. We just crashed there for a second. Why did that just crash? I think I had a bad world there. Oh, it is? Okay, cool. Yeah, I approve. Okay, let's do a new world. Test world 2. Okay, yeah, I think that world was just corrupted. Okay, let's see if we get any extra information now. Yeah, you can see FPS is pretty good here, but then once I go and I start pointing at things, oh, it slows down. That's not good. Okay, so let's go ahead and see. How do I capture a frame? Press F12. Okay, so F12. Yep, okay, that's capturing the frame. Okay, cool. So I think, yeah. Let's see what's happening here. That just crashed. Why did that just crash? Render doc. I don't get why that just closed. I don't know. It's weird. Try again. Render dock. Nope. What's happening now? I feel like this is still running in the background or something. Nope, I don't think it is. Okay, that's weird. Yeah, it lost like all of its... Weird. Okay, I don't know why that crashed. Can I open the capture that I had? No, I don't think I can, unless it saved it somewhere. Okay, whatever. We'll just launch it again, and hopefully it doesn't break this time. Okay, let's go here. Yep, that's good. And try this again. Sometimes if you have something really wrong, it just crashes. Okay, so maybe I have something just horribly wrong and it's killing render dock. That's good to know at least, right? That it's really wrong. Nope, okay, that just crashed again. Let's go ahead and do this again. I feel like I have this like saved somewhere, these settings, but I can't remember where. Okay, do that. If it crashes again, I am guessing we have something just horribly wrong, and that requires even more debugging. That I will probably do in my off time, because we've been streaming for like almost 3 hours now. It's getting pretty long stream. Okay, so if I hit F12, yeah, it captured the frame all right. So that's weird that it would capture it and then it would just break. Maybe it crashed because the first time your app crashes and then you start it again. I don't know. Well, no, that's different. So that's if the world was corrupted on save, which happens when it crashes. Yeah. Is this clone able to run your favorite Skyblock mod pack with 356 mods? It is not. I'm sorry. Maybe one day. Right now, though, definitely not. Okay, yeah, it just crashes again. The game still hasn't crashed. Just render dock. I probably should have saved that capture. Huh. I'm probably going to debug this more in my off time. I'm guessing I'm probably just like sending bad vertices or something, or not uploading them properly, and it's getting like null pointer exception. Maybe something like that. Who knows? For all those of you who are here real quick, I'll show you like a quick sneak peek of the next episode that's going to come soon, because it's got some pretty cool animations and stuff. And trust me, it takes a long time to edit this stuff, which is annoying. But I am getting very close to the end. So this is one of the animations I have for tessellation, and I think it's actually looking pretty cool, just to visualize it and stuff. And it's even cooler when you actually have audio and music and everything. And you see 7 played animations. There's a lot of animations. Yeah, man. So... cool visualization for tessellation and stuff, and there's going to be a lot more, and it's going to be a lot better when it has all the editing attached to it. So yeah. Anyways, though, I just want you guys to know that I am working on the next episode. It just takes a really long time to edit all these because I have to hand code all of this stuff, which is all the animations. Not fun to do all this. I just like buckle down and code for like hours and do animations and edit and everything. But yeah, anyways, that's besides the point though. That episode's coming soon. I'm going to debug this more in my off time. Probably not today because I've got a pretty busy today. So yeah. Oh no, don't stop the stream. I'm sorry, man. It's been 3 hours. I've got to like go do some other errands and everything because I have quite a bit to do today. But Leviska. Okay, I'm sorry if I mispronounced your name, but thank you for following, and welcome to the Epic Minecraft Club. Okay, guys, I'm going to end the stream here, though. I will see you guys next week. I might stream random days, Monday through Friday next week at 8 a.m. Central Standard Time. So keep an eye out. Follow if you want to get notified of that, or join the Discord, and you can get notified of that as well. But yeah, I'll see you guys next time. Thank you all for coming and watching.